Okay, good day, everyone. Welcome to Ice Cream Maths Academy, where numbers actually meet mastery. Today, we are going to be looking at integration by parts. In our last class on differentiation of products using the product rule, product functions using the product rule, we said if y is equal to uv, where u and v are functions of x, we said the y all over the x, is equal to v the u all over the x plus u the v all over the x. Yes, if y is equal to uv, the y all over the x, we said, is v the u all over the x plus u the v all over the x. That's differentiating product functions. Now, today we are looking at integrating product functions. Now, let's look at this. Integrating both left hand side and right hand side. Okay, now if you look at this now, here at the left hand side we have the y all over the x. At the right hand side we have v the u all over the x plus u the v all over the x. So it means this is the same thing as saying integral the y all over the x with respect to x is equal to integral v the u all over the x with respect to the x plus integral u the v all over the x with respect to the x. Yes. Now, this is the same as saying integral d in bracket. Now, remember the value of this y here is uv. So we have d uv all over the x with respect to the x, and we said it's equal to integral v the u all over the x dx plus integral u the v all over the x with respect to the x. Now, in this case, when you integrate this, yes, when you integrate this, you'll be left with uv. Here we have uv, that is this uv. This should be equal to integral v du. Yes, integral v du, because this will go with this. And here we have plus integral u the v. Yes, integral u the v. Now, it therefore means that here uv minus v the u, that is integral v the u is equal to integral u the v. Yes, it's equal to integral u the v. So it therefore means that integral u the v is the same thing as uv minus integral v du. So now we are going to be looking at some examples. This is called integration by parts. Yes, integration by part. Now let's look at the first example using this integration by parts. Okay, now let's target example 1. Example 1. Evaluate integral x squared sine x dx. Yes, integral x squared sine x dx. Now looking at this is actually a product of two functions. Yes, x squared and sine x. Now, u and the v. Now in this case, we are going to assign one of this function to u and the other one to the v. Now, solution. Now, let u be equal to x squared, and the v be equal to sine x dx. Yes, let u be equal to x squared, this, and the v be equal to sine x dx. Now, if u is equal to this, let's see our du all over the x. Now the u all over dx, when you differentiate x squared, it gives you 2x. Yes. And the u will be equal to 2x dx. Yes. The u is equal to 2x dx. Now, if the v is equal to sine x dx. Now, let's see v. Yes. Now, v now will be equal to integral the v. Yes, because when you integrate the v, it gives v. So now that will give us integral sine x. Then here we have the x. Of course, we know when you integrate sine x. Yes, when you integrate sine x, you have minus cos x. Yes, when you integrate sine x, we have minus cos x. Yes, because integration is actually the reverse aspect of differentiation. Remember, we said when you differentiate sine x, it gives you cos x. So it means when you integrate cos x, it gives you sine x. When you differentiate cos x, it gives you minus sine x. So it means when you integrate sine x, it will give you minus cos x. Now, looking at this relationship here, we said integral u to v is equal to uv minus integral v du. Now we have the whole of these functions, the parameters, we have them. So it means now integral u, and our u is x squared, then the v, the v is sine x dx. Now we said it will give us uv. Now our u is x squared, so you pick x squared in place of u. We have x squared, then our v, the value of v is minus cos x. Then here we have minus integral. Yes, minus integral. Then we have v. Our v is minus cos x. Then we have the u. The value of our du now, remember we said the u is 2x dx. So now we have 2x here. Then we have 2x dx. Now let me put it here, please. We have 2x dx. So it means the whole of this now will be equal to, when you expand this, we have minus x squared cos x. There's minus here. There's minus here. So it becomes plus. Now 2 is a constant, so I can take 2 out. So we have 2 integral. Here we have x cos x dx. Okay, that's not all about this. Because as you can see, we still have product of two functions here. Yes, we still have product of two functions here. So at this point, now I will say, let u1, or let me see the value of u now. I'm looking at this now. Let u be equal to x, and the v be equal to, here we have cos x dx. So it means at this point, the u all over the x, when you differentiate x, it gives you 1. And the u will be equal to 1 dx. Yes, when you cross multiply, the u will give you 1 times dx. So here we have 1 dx. Now let's see v. Our v now will be equal to integral. We have the v. Yes, which is the same as saying integral cos x dx. And when you integrate cos x, it gives sine x. Yes, when you integrate cos x, it gives sine x. So it therefore means that integral x squared sine x dx, x squared sine x dx will be equal to, here we have this now, look at it here. We have minus x squared cos x plus 2 integral the whole of this. And to integrate this now, we have in brackets. Now we are repeating this again. Yes, we are repeating uv minus integral v du. And here our u this time is x. Our u is x. And our v is sine x. So we have x sine x, x sine x. Then here we have minus integral v du. And remember our v is sine x. So here we have sine x, then we have du. Now du is 1 dx. So here we have 1 dx. Now the whole of this. So it means integral x squared sine x dx will be equal to, here we have minus x squared cos x plus, if you multiply this, we have plus 2x sine x, then here we have minus, so 2 times minus 1, that will give us minus 2 integral sine x times this, that will give us sine x dx. Then here we have plus, let's call it C1, constant. Okay, let's call it C1, because that's not the final constant. So it means at this point, what we have now will be minus x squared cos x plus 2x sine x minus 2 in brackets. When you integrate sine x, it gives minus cos x. Then now we can call it plus c. So at this point, integral x squared sine x dx will be equal to, we have minus x squared cos x plus 2x sine x minus minus is plus. So we have plus 2 cos x. Then we have plus c. So that is the integral of this function. Now let's look at it again. From here, we said evaluate integral x squared sine x dx. Now, using this integration by parts, we said when you integrate u to v, it gives uv minus integral v du. So here we are saying let u be equal to x squared and the v be equal to sine x dx. That's the whole of this. Now, when you differentiate this x squared, the u all over the x will give you 2x. Now the u cross multiply, because this 2x same as 2x over 1. When you cross multiply, you have the u will be equal to 2x dx. Now the v, we said the v is equal to sine x dx. Now to get the value of v, you have to integrate this now, because the integral of the v is the same thing as v. So integrating the v, we are integrating sine x dx. So when you integrate sine x, it gives you minus cos x. So now looking at this integration by part formula, we said integral u to v is equal to uv minus integral v du. Now integral x squared sine x dx. Now we pick u. I remember we said let u be equal to x squared. So that's our u. Then now the next thing is v. Now we actually said let the v be equal to this. So v gave us the integral of sine x dx, which is minus cos x. Look at it here. So now we have uv now. Then minus the integral of v. Now the value of our v is minus cos x. Then the u. Now the u is 2x dx. So we have 2x dx. 2x dx. So here, x squared times minus cos x is minus x squared cos x. Minus times minus is plus. And here we have 2x. So because 2 is a constant, we brought it out. So we have 2 integral x. Then we have cos x dx. Now, this is another part, integration by parts, because here we have two functions. We have x and cos x. Now, at this point, we are repeating this. We say let u be equal to x and the v be equal to cos x dx. So, if u is equal to x, it means the u all over the x, when you differentiate x, it gives you 1. Now, cross multiplying, our du will be 1 times the x, which is 1 dx. Now v is equal to the integral of the v. So now we are integrating cos x dx, and that will give sine x. When you integrate cos x, it gives sine x. So it means the whole of this now, integral x squared sine x dx will be equal to, we have this there before, plus, now this 2, look at the 2 here. Now the whole of this now, we are repeating this again. So we have uv. Now remember our new u, the u now is x. Our v is what? V is sine x. So we have x sine x. Then minus integral v. Our v is sine x. Look at it here, sine x. Then the next thing here is du. Our du here is 1 dx. So we have it as 1 dx plus constant. Now partial constant. Now at this point, we have minus x squared cos x plus 2. Now, x times sine x. X times sine x. We have 2 times x sine x. That will give us 2x sine x. Now we have minus 2 times the whole of this now. That will give us 2 times integral sine x dx. Okay, plus c1. Now in this case, what we have now will be minus x squared cos x plus 2x sine x minus, look at the 2 here, minus 2. Now when you integrate sine x, it gives minus cos x plus c. Since we don't have any integral here, unlike here where we actually kept c1. So at this point now it becomes c, the full c. So here we have this times this, that will give us this, plus this, minus times minus is plus, 2 times cos x is 2 cos x, then we have plus c. So this is the integral of this. So thank you so much for watching, and watch more for more examples. Thank you so much.